From the smallest atom to the largest galaxy, the universe is a place of awe-inspiring complexity. We humans, with our insatiable curiosity, strive to understand the cosmos and our place within it. Physics, the study of matter and energy, provides crucial tools for this grand endeavor. It reveals the fundamental laws governing the universe's behavior. But what happens when these laws lead us to strange, even unsettling conclusions? What if our understanding of reality is fundamentally flawed? These are not merely abstract philosophical questions. They are brought into sharp focus by the mind-bending concept of Boltzmann brains. Named after the 19th century physicist Ludwig Boltzmann, this thought experiment challenges our most basic assumptions about consciousness and existence. It forces us to confront the possibility that our reality as we perceive it might be a fleeting illusion. Imagine for a moment a universe filled not with stars and planets, but with thoughts. These thoughts are not organized into minds as we know them. Instead, they exist as isolated, fleeting entities. This is the essence of the Boltzmann brain concept. It proposes that in a vast and chaotic universe, random fluctuations can lead to the spontaneous emergence of conscious entities. These entities, known as Boltzmann brains, would possess memories, sensations, and even a sense of self. However, their perceived reality would be entirely illusory, a product of the random arrangement of particles that brought them into existence. They would be like characters in a dream, unaware of the true nature of their existence. The Boltzmann brain concept presents an interesting paradox. If the universe is truly governed by the laws of physics as we understand them, then it should be far more likely for a Boltzmann brain to arise spontaneously than for a complex and ordered universe like ours to form. Yet here we are, experiencing a seemingly stable and consistent reality. This discrepancy between theoretical probability and our lived experience is at the heart of the Boltzmann brain paradox. It suggests that our understanding of the universe might be incomplete or even fundamentally flawed. It compels us to confront the unsettling possibility that our existence might be a cosmic accident, a fleeting anomaly in the grand scheme of things. To grasp the origin of Boltzmann brains, we must look into the realm of thermodynamics, a branch of physics dealing with heat and its relation to other forms of energy. Central to thermodynamics is the concept of entropy, a measure of disorder or randomness within a system. The more disordered a system, the higher its entropy. The second law of thermodynamics states that the entropy of a closed system, like our universe, can only increase over time. This implies that the universe is constantly moving towards a state of greater disorder, a concept known as the heat death of the universe. In this eventual state, all matter and energy would be evenly distributed, resulting in a uniform and lifeless expanse. However, within this inexorable march toward disorder, there exist tiny pockets of resistance. These are known as thermodynamic fluctuations. Imagine a perfectly still pond. Suddenly, a small ripple disrupts the surface. Similarly, in the vast sea of cosmic entropy, random fluctuations can occur, momentarily decreasing entropy in localized regions. Most of these fluctuations are insignificant, quickly dissolving back into the background chaos. But given enough time and a sufficiently large universe, a truly remarkable fluctuation could occur, one that assembles matter and energy into a highly ordered structure, such as a conscious brain. This is the essence of the Boltzmann brain hypothesis. It posits that it is statistically more probable for a single self-aware brain to spontaneously coalesce from random fluctuations than for an entire universe, with its intricate structures and laws of physics, to come into being. Imagine a solitary brain, adrift in the void, complete with memories, thoughts, and sensations. This is a Boltzmann brain, a fleeting flicker of consciousness in the face of cosmic indifference. Its existence would be brief, its perceived reality an illusion woven from the fabric of chaos. The Boltzmann brain concept challenges our intuitive understanding of the universe. It suggests that our existence, rather than being a product of billions of years of cosmic evolution, might be a mere blip in the grand scheme of things, a random accident in an otherwise meaningless universe. The Boltzmann brain hypothesis presents an interesting paradox, one that strikes at the heart of our understanding of the universe. It stems from a simple yet unsettling question: why do we find ourselves in a vast, complex, and seemingly ordered universe, rather than experiencing reality as a solitary, disembodied brain? According to the principles of statistical mechanics, a universe filled with Boltzmann brains is far more probable than a universe like ours. Think of it this way. It's easier to randomly assemble a handful of Lego bricks into a simple structure than to shake a box of millions and have them spontaneously form a complex, intricate model. Similarly, in the grand cosmic lottery, a solitary, fleeting consciousness is a far more likely outcome than a universe teeming with billions of galaxies, each with billions of stars. The unlikely universe. Our universe, with its finely tuned laws of physics, its intricate structures spanning from subatomic particles to galactic superclusters, seems impossibly unlikely. Yet here we are, observing its wonders, pondering its mysteries. This stark contrast between the probable and the actual constitutes the core of the Boltzmann brain paradox. If the universe is truly governed by chance and randomness, then our existence, along with everything we observe, becomes deeply unsettling. It implies that our perception of a stable, consistent reality might be a cosmic illusion, a fleeting anomaly in a sea of chaotic fluctuations. A matter of perspective. The Boltzmann brain paradox forces us to confront our anthropocentric biases. We tend to view the universe through the lens of our own existence, assuming that our reality is somehow privileged, that the conditions necessary for life as we know it are fundamental aspects of the cosmos. However, the Boltzmann brain concept challenges this view. It suggests that we might be nothing more than a statistical fluke, a random arrangement of particles that briefly attained self-awareness in an otherwise indifferent universe. Our existence, in this context, would be a cosmic accident, a fleeting flicker of consciousness in the face of unimaginable vastness. A shift in cosmic perspective. The Boltzmann brain paradox has some implications for our understanding of the universe. It challenges the Copernican principle, a cornerstone of modern cosmology, which asserts that Earth and humanity do not occupy a privileged position in the cosmos. If our universe, with its life-harboring conditions, is a statistical anomaly, then perhaps we are not as insignificant as we might think. This paradox also raises questions about the nature of fine-tuning in physics. The laws of physics, as we currently understand them, seem perfectly calibrated to allow for the emergence of stars, galaxies, and ultimately life itself. However, if Boltzmann brains are more probable than complex universes, this fine-tuning might be nothing more than a cosmic coincidence. Perhaps the most unsettling implication of the Boltzmann brain paradox lies in its challenge to our understanding of consciousness. If our own minds could be the result of random fluctuations, how can we be certain of the reality of anything we perceive? The very ground of our existence, the feeling of I that underpins our thoughts and experiences, could be a fleeting illusion. This existential uncertainty resonates with philosophical ideas like solipsism, which posits that only one's own mind is sure to exist. While the Boltzmann brain concept does not necessarily endorse solipsism, it highlights the difficulty of establishing the reality of an external world independent of our own minds. The concept of Boltzmann brains, while intellectually stimulating, has drawn its share of criticism. One of the most compelling arguments against their existence centers on the inherent fragility of biological systems like the human brain. Our brains are not isolated entities, spontaneously arising from the void. They are products of billions of years of evolution, intricately interwoven with the environments that sustain them. A Boltzmann brain, materializing in isolation, would lack the intricate support system necessary for its survival. Without a constant supply of oxygen, nutrients, and a stable environment, such a brain would cease to function almost instantaneously. It's like imagining a heart beating independently, disconnected from the lungs and circulatory system. The very concept seems to defy the fundamental principles of biology. Another point of contention revolves around the probabilistic calculations that underpin the Boltzmann brain hypothesis. Critics argue that these calculations, while mathematically sound in isolation, might not accurately reflect the true likelihood of such entities arising in our universe. The universe is not a simple, static system where probabilities can be easily calculated. Factors like quantum mechanics, the nature of dark energy and dark matter, and the possibility of a multiverse could significantly alter the odds. Our current understanding of these phenomena is still evolving, and it's entirely plausible that future discoveries could render the Boltzmann brain scenario far less likely than initially proposed. Despite the criticisms, the Boltzmann brain paradox remains a valuable thought experiment. It forces us to confront the limits of our knowledge and to question our assumptions about the nature of reality, consciousness, and the universe itself. Perhaps the most fruitful approach is not to seek definitive answers about the existence or non-existence of Boltzmann brains, but rather to use the paradox as a springboard for further inquiry. By exploring the implications of this thought experiment, we gain a deeper appreciation for the interconnectedness of physics, cosmology, and philosophy. We are reminded that our understanding of the universe is a work in progress, and that even the most seemingly absurd ideas can lead to profound insights. Whether or not Boltzmann brains actually populate the universe, the very act of contemplating their existence pushes us to expand the boundaries of our imagination and to embrace the sheer wonder of the cosmos.